Hello. All right. Yep. Today I will talk about the native TypeScript in Node.js. Well, I was already introduced. I'm a security engineer at Devs and member of the Node.js Technical Steering Committee. And let's get started. So, one of the latest trend in the industry is definitely AI. So this is from 2024, from GitHub, and in 2024, Python was the first language in terms of growth on GitHub, and second came TypeScript. But this trend changed in 2025. Yeah, as we can see, this is still 2024, Python on the rise. In 2025, TypeScript went back to the first place. So TypeScript is the fastest growing language on GitHub, and Python now is second. So this shows a little bit that even though now we have AI has been out for a few years, TypeScript has proven to be one of the easiest languages for developers and for AI in general. And interest, the largest code base are still in TypeScript and JavaScript. As you can see, there is a huge difference between the usage on GitHub in JavaScript and TypeScript and with Python. What does it mean? It means that TypeScript is very popular. Also, Node.js downloads have skyrocketed in the past year. Since around October 2024, the number of downloads of Node.js went up by a lot. Also, these are the downloads of the TypeScript npm package. The amount of downloads, they keep increasing. This is around 20 million downloads per day, which is an impressive number for an npm package. So all of this to say that TypeScript is king, is very popular, and people want to use TypeScript, and even with AI, TypeScript is one of the most important languages for the community. And in Node.js, we have been discussing about supporting TypeScript directly for many years. We have received a lot of feature requests, a lot of issues, and there has been a lot of discussion on how to improve the developer experience for TypeScript. But this was not an easy task. So why other runtimes were able to support TypeScript before, and why it took so long for Node.js to be able to support TypeScript? So the first and most important issue is that TypeScript and Node.js move at two different speeds. This is the release schedule of Node.js. The lifetime of a Node.js release is about 3 years. So from when the release is cut to when it goes end of life, it's 36 months. In contrast, TypeScript has a very fast-paced release, about one minor every 3 months. I think it changed. And also, TypeScript releases can have, even minor releases can have breaking changes in the type checking. So this means that if Node.js were to embed in the runtime the TypeScript library, it would not be updated for 3 years, which is unthinkable. So this is one of the main issues. The second issue is that until this year, Node.js was still struggling with CommonJS and ESM interoperability. So adding another module to the runtime was probably not a good idea, but now that this problem has been fixed, it got much easier to add new modules to the runtime. Another issue is that TypeScript, when performs the transpilation, it requires source maps. And the source maps are can cause overhead in the runtime because of reconstructing the location inside the file. When you throw errors, there is a lot of overhead involved and technical complexity that it was something not desirable for Node.js. And finally, the lack of a champion. So there is a big misconception around Node.js. I will quote this tweet from Joey. If you attended her talk, you've already seen this. But basically, there is not a Node.js team. There is no such thing as Node.js team. And most of the work is done by volunteers like me who do it as an hobby. So even though a lot of people wanted this feature, it required someone to do it, to do the work. And yeah, so last year in July 2024, I sent this PR to Node, which it's called Add Experimental Strip Types. As you will see, it's not called Add TypeScript because it's a slightly different technique from the TypeScript that we all know. It's a bit different, but this PR landed, and it's actually one of the most upvoted PR on GitHub, like I think in the top 10. So it went became very popular, yeah. So type stripping is not something new. So it works like this. Imagine this is a TypeScript file. You have an interface and you have a bunch of types. So imagine we take an eraser and we remove everything that is not JavaScript, and we simply canceled it because at runtime it does not have any effect. So we just remove it. And then we go ahead and remove another piece, and there we go. We end up with valid JavaScript. So this is JavaScript. But the issue here is, so this is something that other runtimes do. For example, Dino, it's not a new thing. But is there a way to preserve locations to avoid source maps? The answer is yes. By replacing the syntax that has been removed with white space. This technique was inspired by TS blank space, and it actually works very well. So you don't need source maps to run TypeScript, but it has some constraints on the kind of syntax that is accepted. So type stripping means no type checking, just transpilation and syntax erasure. No JSConf, because what we wanted here is JavaScript plus some types, and we didn't want complex TypeScript configuration. It's just Node.js, the JavaScript you're used to work plus inline types. No source maps because they are not needed. And finally, stability across TypeScript versions, because by removing TypeScript syntax, we make it, the basic syntax is stable, because the unstable part of TypeScript is the type checking. And since we don't perform type checking, the core of the syntax is stable. So this is achieved through a library that is embedded in Node core that is called Amaro. Amaro uses SWC inside to perform this transpilation. It's an NPM package that can also be used as a standalone package. So inside it uses SWC WASM TypeScript, which is a version of SWC in form of WASM. The reason why we wanted WASM is because Node.js does not support Rust in the core, so we wanted something that was portable to all the platforms supported by Node.js, and SWC is written in Rust. It's battle tested because SWC is used by Dino and it's used by a lot of popular packages in the ecosystem. It's very fast, so the performance was good enough. And finally, we received a lot of support from the SWC maintainers. We were able to ship this package in less than a week. So that's why we were able to land type stripping very fast. So what are the constraints? So the good thing is type stripping is fast, does not require source maps, but not all TypeScript syntax is supported. The reason why is that some syntax requires transformation. Let me give you an example. We have a namespace that exports a function, and we have enums. So this syntax cannot be erased because it has a runtime value. So you cannot just erase it from the file. In fact, when you transpile TypeScript, the output JavaScript will look like this. So this is after transpilation. When you use enums, it will become a function like this in pure JavaScript. And this is something undesirable because this requires source maps. And so we decided to not support these features. But also TypeScript in version 5.8 introduced a new flag called erasable syntax only that will throw an error wherever it encounters this kind of syntax that requires transformation. So enums, namespaces, parameter properties. So here there is the whole list of features that are not supported. Import something equals require, as you can see, a lot of TypeScript only features and enums. So, but we also wanted users that had existing code bases with these features to use the native TypeScript support. So we created this flag called experimental transform types that allows you to execute these features and transpile. It also means that you enable source maps with all the overhead and issues that brings. This feature is experimental, so I would not recommend to use it in production. Another constraint is that we decided not to support features that required polyfill. A common example of this are decorators. So decorators are very popular in TypeScript because of frameworks like Nest.js that have a heavy use. But since they will eventually they will be supported by the JavaScript specification and by the JavaScript engine, we decided not to transpile those. So whenever Node.js encounters decorator, it will not transpile it, and whenever the JavaScript engine will support it, it will be support. Otherwise, it will throw a runtime error. Another constraint is Node.js imports for TypeScript file. So whenever we use TypeScript for a very long time, we had to use the .js extension whenever we're importing a file, even though that file was TypeScript file. There was a way to enable the TypeScript importing TypeScript file with the .ts extension, which is allow importing TS extension. But whenever you try to transpile, it will emit this error that you cannot transpile TypeScript. This is because at the time it was thought that it's dangerous to rewrite the extension during the transpilation because of all the edge cases and possible shenanigans that people do with TypeScript. But eventually, the TypeScript team changed their mind. So in TypeScript 5.7, they added a new flag to rewrite this extension during the transpilation. The example is this one. So if you use dash rewrite relative import extension, if you whenever you do import foo from foo.ts, it will during transpilation rewrite the extension into .js, and so you now can transpile using the .ts extension, which is huge. In my opinion, it's one of the best features that TypeScript has pushed lately. Another constraint is that whenever you use you import a type or something that is erased at runtime, you need to use the type keyword. This is enforced by the TypeScript flag verbatim module syntax. So, for example, if you import a type, you need to use the type keyword here. If you don't, this will throw at runtime, because Node.js will not erase the import and will look for the export. But the export, since it's a type or an interface, will be erased. But the import will not be erased, so it will throw an error. But if you use verbatim module syntax, this will throw during type checking. And finally, no running TypeScript in node modules. So this is a design choice. So if you try to run TypeScript inside a node modules folder, inside the path, it will throw this very long error here, unsupported node modules type stripping. The reason why is to discourage people from publishing TypeScript on NPM. It's not because Node cannot support it, but it's to avoid chaos in the ecosystem. Also because IDEs need to perform type checking into node modules, and this will slow down a lot the type checking, and your IDE might get very slow because of this. And in general, there are some compatibility concerns about consumers flag. So it was asked by the TypeScript team not to support TypeScript in node modules. We will see how this evolves, but for now, that's how it is. So this is the JSConf that you can use to run TypeScript natively. So Node will ignore the JSConf. This is not for Node.js. This is for your IDE. So whenever you do the type checking, you have the right configuration for TypeScript. So as I said, rewrite relative import extensions, verbatim module syntax, and erasable syntax only are the main flags that you need for the native support. So this is a funny example here. So while I was working on the TypeScript feature, a collaborator suggested this piece of code. So raise your hand if you think this is TypeScript. This is TypeScript code. Yeah, of course it is. All right. So whenever we try to execute it inside Node.js, we get false. The output of this code is false. So I thought there was a bug in my implementation, and I went to the browser, and it's also false. So what's going on here? So because this code is actually valid JavaScript, and if you, this was my reaction. I didn't know this was possible. And so imagine it like this: you are comparing a function with an object with a string, and the output is false because JavaScript. And so there is some syntax ambiguity. In fact, if you run this code in the playground, you will get a fetch. So it has the same code has two different behaviors if run as TypeScript or if run as JavaScript. So how did we handle this in Node.js? Because Node.js has support for code evaluation, so we needed a way to work around this. So how does syntax evaluation detection in Node.js work? So imagine this string here. We have export const foo hello world. This is ESM because it has the export keyword, and it's also TypeScript because it has the string type. So in short, Node.js needs to do a lot of evaluations to make sure it detects the right syntax. For example, this is a bit simplified, but it first tries as a common JS module. But this is not a common JS module because this is ESM, so this will fail. It will try again as an ESM module, but this is TypeScript, so it will fail again. And it will try another time if the previous error was a syntax error. It will try to strip the types. So once it has stripped the types, the string looks like this. There is a hole because we have removed the string type declaration. So this is again valid JavaScript, and we have to run it again. We have to make sure that it's not invalid code at all, and we have to make sure that we preserve the error messages. But in short, we have to run it again as common.js, and it's not common.js, so we run it a final time as ESM, and finally we have detected the syntax of a piece of code. So this is very expensive. As you can imagine, we are evaluating code many times to understand which kind of syntax you're using. So you can skip all of this detection by passing the module TypeScript, the input type with module TypeScript or common.js TypeScript. This will go directly to the right case. And in fact, if we use this input type, the previous code that was printing false is now performing a fetch. Okay, so yeah, so this was something I encountered while implementing this feature. So what is happening? What's the current status of this feature? So a few months ago, I opened a PR to remove the experimental warning. So this feature at the time did no longer emit a warning. Then this feature was also backport to Node 22, which was the active LTS at the time. So you can use this running TypeScript natively in 22. And finally, this feature is now stable. So last week in Node 25.2, the stability index was changed to stable. So this was the story on how you can finally run node file.ts and it will just work. Thank you very much.
Here's time for Q&A to question.
Okay, question?
Yeah, so earlier you were talking about essentially how like the behavior between fetch and JavaScript versus fetch and texture. Essentially, if you wanted to get the JavaScript effects, would you are there any potential ways that you could allow some unsafe JavaScript code, or is that a little too messy and you just should probably write it in JavaScript?
I'm not sure I understood the question. So this was an edge case that is very unrealistic in application, because it's very rare to write such a short piece of code, and this syntax ambiguity is very rare in the wild. But we had to make a decision in the runtime to choose whether to evaluate in TypeScript first or in JavaScript first. And the the output was that JavaScript should be evaluated first. So if something is valid JavaScript, it should be evaluated as JavaScript, because otherwise that would be a breaking change. And this also is true for errors, because if something that previously was throwing an invalid an error, syntax error for whatever reason, the error needs to be preserved even though it is stripped after it types. So there is a it's quite complex, the whole process of evaluating syntax, but that's why we decided to to evaluate JavaScript first, basically.
I think that's all the time we have. 時間が終わりましたが、ありがとうございます。
Thank you.